Hey, today we're going to talk about 6.3, fuel types and uses. Take a moment, check out the Enduring Understanding, look at the learning objective, pause the video, review the essential knowledge, and set up your Cornell notes. So, globally, wood is the leading fuel source, and this is because wood is very cheap, it is readily available, but also a majority of the world lives in developing nations. So their access to higher or different forms of energy are not really that accessible. So 2 to 3 billion people worldwide have wood as their primary fuel source, and that is for cooking. And a lot of these countries are developing and they're in more tropical areas, so it's not for home heating, but it is definitely for cooking. Now, another thing, like about 6 million people in the United States use wood as their fuel source, energy source. Growing up, my parents, I came from Minnesota, we went out and cut trees every fall. And we had a wood burning stove. Now we had electric for cooking. My grandparents still used a wood burning stove for their actual oven. Like they put wood into an actual stove in their kitchen, like an old timey. They were old, like born in the early 1900s. So that is still common. The problem is when you burn this in your home, it can release a lot of particulate matter. And particulate matter is like soot, and the smoke and the soot can cause respiratory illnesses, and that's a major problem, which we'll definitely be discussing during the air pollution unit. A lot of people also use charcoal, and charcoal is made from wood, and it's when it's been heated under low oxygen conditions. So it basically is superheating the wood. It's kind of like burning it, but it makes it look like coal, but it's actually wood based. So coal has a very long drawn out process for its formation. It starts out initially as plant biomass, and then under anaerobic, that means without oxygen, and acidic conditions, it is through partial decay of this vegetation, you get what is called peat moss. And peat is just partially digested organic matter. It has a very low heat content, which means you can burn it. You can get some benefit from it. It will heat it, but it will not give you as much heat as coal. Now, if you let this sit longer and under pressure and heat, lignite will form. And this is over, millions of years. But lignite has a low heat content and a low sulfur content. So because it has a low sulfur content, it will contribute less to acid precipitation, which we'll discuss in future lessons. It is typically used, lignite, because of its availability, it is used for electricity generation. Now, if you let this go even longer, you'll get what is called bituminous coal. Bituminous coal has a very high heat content, so it will burn at very high temperatures, but it also has a high sulfur content, so it's not really beneficial for wide-scale usage because it can contribute to acid precipitation. So this is typically used in industry and manufacturing in steel production to get those high temperatures for manufacturing steel. And finally, the most pure form of coal is anthracite. It has a high heat content and a low sulfur content. And because the low sulfur content, it is good for home heating or heating where there's going to be humans involved. So when you want to eliminate or reduce the sulfur content because again, it can contribute to acid precipitation. So petroleum or oil is formed kind of not really similar, but it takes a long time for it to form, just like coal. Just like coal involved plant biomass. Petroleum involves phytoplankton in oceans. So coal was more in like old, ancient forests, that have built up the biomass, and petroleum is from microorganisms that have settled to the bottom of the ocean. So we have prehistoric phytoplankton is found in ancient oceans, and then they die, sink to the bottom of the ocean, and then sediment will cover the dead organisms. And then you have much pressure, and you're getting petroleum that's forming under this porous rock. And then it rises through the porous rock, and then it's going to collect in a reservoir. Now, basically what you're doing with coal and petroleum is, well, and natural gas as well, is you're basically isolating the carbon, and you're condensing it, so to speak. So you have a lot of carbon that's present in the organic material found in organisms, and when you subject it to this heat and pressure, you're basically like concentrating this carbon. And this is why these make really awesome fuel sources, because they have all this built up energy. Now, after you obtain your petroleum, it's called crude oil when we pull it up out of the ground. We refine it for future use based on different temperatures. So things that come from petroleum: asphalt and tar for paving roads. You have diesel fuel, gasoline, kerosene, and also plastics. Plastics are made from petroleum, if you didn't know that. So how do we make this or distill this petroleum? Basically, what you do is you take the crude oil, you heat it up in this boiler, and then you collect it based on the boiling point. So the lowest boiling point is going to collect first, and that's petroleum gas. And then you're going to get gasoline after you isolate the next highest boiling point. You're getting naphtha, which makes plastics. Paraffin, which is like a wax. You have diesel fuel. Then you have fuel oil. These have really high boiling points. And lubricating oil. And then finally bitumen. Bitumen is it's basically like a really very viscous, kind of sludgy, almost like a tar material. And you can use it in paving and in highway construction. Now, natural gas is found very often. It is found in an area where you have petroleum. So if you have oil, chances are you also have natural gas. And natural gas basically pools in this little area above the oil reservoir. So natural gas is just methane, CH4. And the way that it forms is, this is basically showing you have this cap rock, which is impervious, so nothing, water can't get through there. You have this reservoir rock, which is permeable, it's porous, and you have the source rock. So the oil forms down here and then rises up through this reservoir rock. This rock again is porous and typically will be sandstone. Sandstone is a sedimentary rock that is over time is permeable. And then you have this impervious cap rock where the oil can't rise any further. And the natural gas just pools in this reservoir. So natural gas, or methane, it's associated with petroleum deposits. So if you have petroleum, probably have natural gas. It has 25 or 24 times more warming potential. I say 24, I say 25. They're both, comparable. Anyway, it's a lot more warming potential than carbon dioxide. So one molecule of methane will warm the atmosphere as much as 24 or 25 molecules of carbon dioxide. It produces half as much carbon dioxide as coal, which is, reducing the amount of greenhouse emissions. And also it burns pretty clearly. And basically you start with CH4 and you're getting a very pure burn. You don't really have a lot of residue. There's very little sulfur dioxide and very little nitrogen oxides. And most importantly, there is no mercury. Mercury is released with the combustion of coal, and that is a really big impact that it has on the environment, which we'll discuss later. Okay, so tar sands is formed from this bitumen formation, which it's basically petroleum or oil that's under a permeable rock. So if you think of like tar, if you think of when they're paving the roads, and sometimes you'll see them like patching up like little cuts, or not cuts, but cracks in the pavement, and you see this like black. That black stuff is like bitumen. It's obtained from tar sands, and this Bitumen, by the way, is also, this is an alternative way of obtaining this substance, because as we have depleted our sources, our resources, we've had to find kind of creative and inventive ways of getting this. So we're using water in this extraction. You use really hot water to basically melt this bitumen and make it a little bit more liquid, less viscous, and this water is superheated for that. Now, this is a form of open pit mining, which can destroy habitats, of course, leading to biodiversity loss. The tar sands also can pollute water, which is a form of pollution, which can contribute to biodiversity loss. But also we can use it to make petroleum products. It is expensive, however, and that is a major drawback for this obtaining this tar sands. We also have something that is done is cogeneration, and cogeneration is when you are you can generate electricity from a fuel source. You can generate electricity and use some of the energy to also heat a home or business. Or if you're generating electricity, which we typically use water, heating it up to steam, you can use that hot water to heat a building. To heat buildings in an area, heat buildings in a neighborhood, in a city, and you are reducing the overall cost of your energy. And that is because you're basically recycling it or reusing some of it. So cogeneration just means generating electricity first and foremost, and then using the leftover heat for another purpose. So to practice, what I would like you to do is to explain 2 environmental benefits of using natural gas as a fuel instead of coal. So I look forward to seeing what you have written. Thank you for your attention. I appreciate your focus, and I will see you soon.